and welcome to our next class, that is mathematics, and also welcome to our channel, that is We Will Change. So today we will discuss about a important thing of trigonometry. Okay, so this is also a rule, and before I tell that rule, previously I told a relationship between the units of angles, that is degree, radian and grade. So first I write the relationship, that is 180 degree equal to pi radian equal to 200 grade. So this is the relationship. We does not consider grade, we consider only degree and radian. So I erase that, I erase this thing. So 180 degree is pi radian. Okay, so from here pi radian is 180 degree. So I can I write pi by 2 radian is also 90 degree? Yes or no? Yes. So radian is here or not does not matter. So pi by 2 in place of 90 degree we can write pi by 2. Then I enter to that rule. Okay, so the name of the rule is ASTC rule. Okay, ASTC rule. So in ASTC rule, we all know this is a number line in coordinate geometry and two axes are there. One is x axis, I named it x dash, and another is y axis. One is horizontal line and another is vertical line. The horizontal line is x axis and the vertical line is y axis. Y dash. This is the positive axis of x and this is negative of x. This is positive axis of y and this is also negative of y. Okay, so you see this is a straight line. Yes, this is a straight line. So this initial angle is 0 degree. We all know initial angle is 0. And this is a vertical line. Yes, so this angle is 90 degree. Okay, this angle is 90 degree. And I tell in place of 90 degree we consider in radian. So I can write here pi by 2. Yes, this is pi by 2. And this is the straight line, this is the initial angle and this is the final angle. Okay, in the final angle this is 180 degree. Yes, so in place of 180 degree I can write pi. Okay, so I erase the degrees, that is 180 degree and 90 degree. Okay, so here 0 degree, here pi by 2, here pi. Okay, similarly here 90 degree and here also 390 degree. Okay, so this is a number line in coordinate geometry and there are 4 quadrants. This is first quadrant, this is second quadrant, this is third quadrant and this is also fourth quadrant. Okay, there are 4 quadrant. This is first, second, third and fourth. So you see in the first quadrant the angles are lies in between first quadrant are less than 90 degree. So the angle lies in between first quadrant, in between 0 to pi by 2 are less than pi by 2 or less than 90 degree. So the angles are lies in between this quadrant are represent as pi by 2 minus if theta is a angle in between first quadrant. If theta is an angle, so I can represent that angle in pi by 2 minus theta. Okay, in pi by 2 minus theta. And in second quadrant, come to second quadrant. In second quadrant, the angles are present in or lies in second quadrant are greater from pi by 2 but less from pi. So the representation of the angles in second quadrant are pi by 2 plus theta or pi minus theta. Getting my words? Here pi by 2 plus theta that are greater from 90 degree and less from 180 degree. So pi minus theta and pi by 2 plus theta in second quadrant. Okay, in third quadrant the angles are lies that represent in pi plus theta are greater from pi. So we consider 4 things: pi by 2 minus theta, pi minus theta, pi by 2 plus theta, and pi plus theta. So I write here ASTC. So four things. So represent four things in fourth quadrant, in four quadrants. Okay. So how we represent this ASTC? You see, can I write A here? Can I write A here? Or can I write A here? Or can I write A here? This is the first quadrant, so I write A here because this is the first quadrant. And can I write A's here? Here? No. I write A's here because this rule follow anti-clockwise direction. Anti-clockwise, clockwise this type and anti-clockwise this type. So this rule follow anti-clockwise direction. So A is here, S is here, also P is here, and C is here. Okay. Now what is A? A for all. A for all. All means all trigonometric ratios, that is all 6 trigonometric ratios on that operation, on pi by 2 minus theta operation are positive. So the rule is for sines, are considered for sines of the operation, that is all trigonometric ratios sines are positive here, that is sine, cos, tan, and also their reciprocals cosec, sec, and cot on that operation are positive. Okay. Come to second quadrant. In second quadrant there is S, that is S for sine. So sine and the reciprocal of sine is cosec. So in second quadrant on that operation pi by 2 plus theta and pi minus theta with sine and cosec are positive. Rest all the ratios are negative on that operation. Okay. So sine and cosec are positive and other ratios are negative on that operation on second quadrant. Okay. Now come to third quadrant. So in third quadrant there is T for tan. So T for tan and the reciprocal also tan is cot. So I write here tan and cot. So in third quadrant the operation of pi plus theta with the trigonometric ratio tan and cot are positive and other ratios for the operation are negative in third quadrant. Okay, then I will write the formulas now. So here pi by 2 minus theta and all ratios on that operation are positive. Here pi by 2 plus theta and pi minus theta are the operations, and in second quadrant sine, cosec are positive and other ratios are negative. In the third quadrant tan, cot are positive on the operation of pi plus theta and other are negative. Then I will write the formulas. Okay. So sine pi by 2 minus theta. So see, we know sine is positive on that operation pi by 2 minus theta. So consider this is first quadrant and sine is positive. So sine is positive. And in pi by 2 operation sine converted to cos. So theta remains same. So sine is positive. In pi by 2 operation the ratio sine is converted to cos. Then I write other ratios. So cos pi by 2 minus theta, that is also sine is positive and the ratio converted from cos to sine and theta remains same. Then I write the rest tan pi by 2 minus theta, that is cot theta, cot pi by 2 minus theta, that is tan theta, sec pi by 2 minus theta, that is cosec theta, and finally cosec pi by 2 minus theta, that is sec theta. So these are the operation of pi by 2 minus theta, and these operations are lies in between first quadrant. Okay, then I write the second thing. Okay, so come to second quadrant and on that operation pi by 2 plus theta and pi minus theta. So I write first sine, the ratio starting from sine, so I write first sine. So sine pi by 2 plus theta. So what is this? you tell sine pi by 2 plus theta. So pi by 2 plus theta, consider this is lies in second quadrant. Okay, sine pi by 2 plus theta. Second quadrant means sine operation, so sine is positive. The sine is positive. And in pi by 2 operation, sine converted to cos. So very easily sine pi by 2 plus theta is cos theta. Now for cos pi by 2 plus theta, cos converted to sine, but here sine is negative because in second quadrant sine and cosec are positive. So sine is positive but other ratios are negative. So here cos, the negative sign also, that is sine theta, cos converted to sine. Then other ratios, tan pi by 2 plus theta, that is minus cot theta. Then cot pi by 2 plus theta, that is minus tan theta. Then sec pi by 2 plus theta, that is minus cosec theta. And finally cosec pi by 2 plus theta, that is sec theta. So cosec is here na, and cosec in second quadrant, so that is sec theta, and sine is positive. Then I will go for the next pi minus theta in second quadrant. So go. So sine pi minus theta. So see, I told here. So in pi by 2 operation, the sine converted to cos, the cos converted to sine, and the rest also. But in operation with pi, the ratio remains same. That is sine converted to remain sine, cos to cos, tan to tan. Okay, cosec to cosec, sec to sec. So sine pi minus theta. Consider this is in second quadrant. So in pi operation and sine remains same, sine and also positive. In second quadrant sine and cosec positive. So sine remain positive, sine to sine remains same, and theta here. Then cos pi minus theta, that is cos. So in second quadrant negative sign and cos remains same because here pi operation. Okay, so cos theta. Then tan, similarly tan pi minus theta, that is minus tan theta. Cot pi minus theta, that is minus cot theta. Sec pi minus theta, that is minus sec theta. And finally cosec pi minus theta, that is cosec theta, because cosec theta is present in second quadrant and positive here. On that operation pi minus theta. So finally I write the last part of that formula. So I write here. Okay, so see, pi plus theta. So first sine pi plus theta. So consider pi plus theta in third quadrant. So in third quadrant the tan and cot ratios are positive and rest ratios are negative. So sine here, so sine is negative. So first consider sine is negative and sine converted to sine because pi operation here, pi. So minus sine theta. Getting my words? Okay. Then cos pi plus theta. Cos remains same, pi operation, sine also negative because in third quadrant tan cot are positive. That is minus cos theta. Okay. Then tan pi plus theta. That is tan theta because tan is positive in third quadrant. Then cot pi plus theta, that is cot theta. Okay. Then sec pi plus theta, that is sec theta minus sec theta because tan cot are positive. And the last one cosec pi plus theta, that is minus cosec theta. So similarly in fourth quadrant the ratios are like that. So thank you, and this is Ssc rule, very easy. And if the things are getting to all of you, so please subscribe our channel and like and share our channel, and I will give some more information about trigonometry and other mathematics background. Okay, thank you. Okay.